Who would have thought that the need for this channel would have become so clear in the very first video? Today we're going to talk about how our very first test video was completely jacked up because Filament sucks. So when we first started filming the videos for the Tangled Testing channel right here, we had a couple of videos in mind, but they were delayed because of what I'm going to explain here in this video and give you just a little bit of context. So we were doing a bend test inside of our compression rig where you have compression going down on the edge of a cantilevered beam. This is fine and easy. Each one of the test samples was made of the same type of PLA and all had iteratively thicker wall thicknesses. Generally, when doing a test like this, if you add more wall thickness, you should expect the strength of the part to go up. That is the hypothesis, and that is actually how physics works. But when we did the test, we did the 1mm wall, it was fine. We did the 2mm wall, it was fine. We did the 3mm wall, it was a little bit more than the last couple. And then we did the 4mm wall, and what would happen? But it dropped off. It got weaker than the one before it. Sure, hypotheses are allowed to be incorrect, but this shouldn't happen because physics. So in order to finalize this test, we need to do more samples, which ended up delaying that video. But we also had to do enough tests to really get into why this was happening. And we will give you our theories as to why this is happening here at the end of this video. But let me tell you about another test next. Now, we also wanted to test that same cantilevered beam with variable infills because how strong a part is when you try to snap it is really important. So of course, we went through and we had 10% to 100% infill. By the way, something really interesting happens when you get to 100% infill, but again, another video. Subscribe to see that coming out later. What was interesting is that between 10 and 20%, there was a big old jump, and then between 20 and 30%, there was a drop off again. And then between 30 and 40%, there was basically no change at all. So again, we need to do a lot more iterations of these. We needed to basically do 3 to 5 of each one of these parts in order to figure out why it's going up and then down and back and down and all over the place. But what came from this video is that there is such a need for testing. The material itself is not behaving consistently when printed with identical settings on identical machines and in a very consistent controlled type of way. It is not performing in a predictable fashion, which is why it's so important for us to do what we're doing here on Tangled Testing, to show what materials have this really high variation, how to avoid them, and what causes it. Now, on to why we actually think this is being caused and why we're going to do more tests with these materials and with some other materials. We think that the issue with this is actually the material itself. It was, quite frankly, a cheap version of PLA, which was also being used for another video that's in production about the cheapest PLAs out there. But we think that since PLA has such a high variation, especially when it's low-cost PLA that's not processed very appropriately, it gets increasingly brittle or durable based on how it's processed. So if the extruder varies in temperature, it can change how the material behaves, or if it's just cooled too quickly or has a bad day or was a little bit contaminated, these types of cheap materials can be very finicky. So our hypothesis right now is that even though we were printing from the same spool, the filament itself was changing within the length of the filament so that the individual sample pieces had different strengths compared to each other and were not behaving in a predictable way. Because regardless of what the material is, it should behave more predictably than the data here initially shows. So in order to get this nailed down, we're going to be doing these videos and these tests again. We're going to be increasing the sample size, and we're going to be using a much more reliable form of PLA so that we actually are minimizing variables to just, is the infill changing the strength? Is the wall thickness changing the strength? And now we don't have to worry about, is the material actually finicky? So this has been really informative to us because we're not able to dive right in. We're having to start at the very fundamentals. First of all, we need to get a control batch of materials that we know are always consistent and the manufacturers are reliable so that we know we will always get what we ask for and have a reasonable sample baseline. And then when we're testing print settings, we can use those control materials so we know what the properties are and know that only the adjustment of the settings is what is causing the issue. But we wanted to show you guys this process because as Tangled Testing grows, videos, it's really important to understand some of the challenges involved and why it's so important to do this. We would not have known that this material was this garbage unless we had done this fairly exhaustive set of tests. I mean, it's only 10 tests, but it shows how radically varied the quality of the material might be. And now it's on us to continue to dive down that hole and make sure it's very clear, very defined, and irrefutable what the problems are so that you guys can reliably go out and pick a material for whatever your project is and know that that material will behave the way you want it to behave. So we just wanted to give you that kind of heads up. This was not our expectation for the first video. We were expecting to have 2 really interesting testing videos about how cantilevered beams behave when put under compression under different 3D printing settings. But now you're gonna have to subscribe to the channel and see those videos come out in a week or 2. Have a great day, everybody.